So now I'm going to go over two problems to show you how we can construct confidence intervals for the difference between two proportions. But I'm also going to go over the interpretation of those intervals. This is oftentimes the most confusing part of confidence intervals, is when you're dealing with two proportions or the difference between them. I know it can be a little bit confusing, but it's important to be precise in the interpretation because you can be misleading or even incorrect if you're not careful with how you interpret these confidence intervals. So here we have a problem that looks at how parents' attitudes towards their teenagers can impact the rate at which students smoke. So they took a group of students who never smoked and were asked about their parents' attitudes towards smoking. For parents that were lenient, only 11 out of 38 smoked. So their parents' attitude towards smoking was lenient and 11 out of 38 smoked. That's a rate of about 29%. For parents that disapproved, 54 out of the 286 smoked. That's a rate of about 19%, so 18.1888. Those are for the stricter parents. So I've notated these PL and PD. I've put PL first because it has a slightly higher rate, and so that way we're going to look to see if there's a positive difference or not. Our standard error then is constructed based on these two proportions. So we're going to square root our whole term. We're going to use these sample proportions to generate our standard error. You can see this is P, this is Q, and then we account for the sample size of those lenient parents. This is the P of disapproving parents, this is the Q of disapproving parents, and then this is the sample size for disapproving parents. When we calculate that out, we get a standard error of 0.0771. Using this standard error, we're asked to create a 95% confidence interval and interpret it. Remember that the critical z for a 95% confidence level is 1.96. So that's how I got this term. We start with our confidence interval with the sample difference. So the sample difference here is the difference between the two groups. We want to make note that we put the lenient group first and the strict group second. That way it's going to impact our interpretation later. And then we reach up and down our margin of error, where our margin of error is just the critical z times our standard error, and we get our 95% confidence interval. So now that we have the 95% confidence interval, we can say we're 95% confident that the true proportion falls within this. But we can say a little bit more about which group we think is larger and which group we think is less than the other group. So here we are provided with 4 interpretations, and we need to identify the correct interpretation for our problem. Remember that our confidence interval ran from -5% to +25%. To start, we want to make note that the parameters of interest are the proportion of teens who will later smoke. We've separated this into 2 groups, those with lenient parents and those with strict parents. So you can see here in this first statement, the proportion of teens with lenient parents who will later smoke, that's what we've designated as PL. So we can just write that as PL is 5% less to 25% more than for teens with disapproving parents. Now, the disapproving parents is what we denoted as PD, and so we can just make note of that. So this first statement says that PL is 5% less to 25% more than PD, which is what we found with our confidence interval before. But let's go through and make sure that none of the other interpretations are correct. If you look at this 4th interpretation, again, we're looking at the proportions and we're saying less and more. And you can see that here we have the proportions of teens with disapproving parents, that's our PD, is 5% less to 25% more than PL. That's in fact the complete opposite of what our confidence interval says. This is what would happen if we were to reverse the order of them and incorrectly interpret them. So again, the first statement is correct of our confidence interval, and this fourth statement is the complete opposite. The second statement is incorrect because it's saying that PD is in fact exactly 5% and that PL is 25%. Now, the confidence intervals don't prescribe percentages to the proportions, they prescribe possible percentages to the difference. And so this second interpretation is incorrect because it's prescribing percentages to the specific proportions. And we don't know what the proportions, the true proportions are. We just have an idea of where the difference is. This third statement then is incorrect because it's stating that PD is always less than PL. And as we saw with the confidence interval, because it's initially negative, a negative term would actually suggest that PD is greater than PL. And so there may be instances in which the disapproving parents' rates are actually higher than the lenient parents. So again, interpretation 1 is the correct interpretation because it doesn't prescribe percentages specifically to each proportion. It's actually just looking at the difference between the two proportions. So let's quickly try one more problem. In this problem, we're looking at the rates at which men and women suffer from arthritis. So they implemented a survey, and you can see in this survey they surveyed slightly more women than men. So you can see more women suffered from arthritis, but we're not interested in the total number of women that suffered. We're interested in the rate, because the rate is a more accurate reflection of the rate of arthritis sufferers. The fact that we sampled more women would lead to the fact that there are more women suffering from arthritis. So again, we want to look at the proportions. You can see when we calculate the proportions out that women in fact have a higher rate than men for these two samples. But we want to know, is this sample difference within a reasonable range, or is it just due to sampling variation? So is this difference large enough to say that these two groups, men and women, have different rates of arthritis? Or is this difference just simply due to the sampling variation? Our standard error accounts for that sampling variation. We're going to square root the proportion of men who suffer from arthritis times their Q divided by their sample size, and then again we're adding to that the rate at which women suffer from arthritis times their Q divided by their sample size. We get a standard error of 0.0218. Once we have the standard error, we can create our confidence interval. Remember that we center our confidence interval around that sample difference. Here I'm putting women first, and the reason why I put women first is just because they're larger proportion, or they have a larger rate, and that will make my interpretation easier, because if we have a positive term, that means women suffer more at a higher rate than men suffer from arthritis. So that's our sample difference. We're going to reach up and down from that sample difference, the margin of error, and the margin of error is just that critical z times the standard error, where our critical z for a 95% confidence interval is 1.96. Again, you can get this from your critical z's that you wrote down earlier. That's going to give us a 95% confidence interval of 4.6% to 13.1%. So we are 95% confident that the true difference between men and women is somewhere in this interval. Now this interval is entirely positive, meaning that 0 is not in the interval. So we actually have evidence that women suffer from arthritis more than men. We are 95% confident that women suffer from arthritis more than men, somewhere between 4.6% more to 13% more. And so that's how this interval is interpreted, as based on comparing men versus women, one group being greater than or less than the other group. So that is all the tests for proportions, both for one proportion tests and for two proportion tests. In the next section, we're going to move on to a new parameter, and we're going to look at the parameter of a mean or an average. And we're going to do it both for a one sample, but also for two samples as well. So some of these concepts are going to begin to look more familiar.